Hello, everybody, and welcome to the third day of lightning talks.
The third and final day.
And final.
Yeah. Right?
Yeah. Woo, yes, boo, projectors.
Boo. Hey, Anthony.
Hey, Paul.
You want to hear a joke?
No.
Okay.
Go ahead.
That was funny enough.
No, that was...
No, maybe later.
It's over. So as you might notice, well, first of all, we got a ton of signups for lightning talks this year. So congratulations to all of you. There's about 60 people, and we will not make it through all of the whole list. So I'm sorry.
All the next year, right?
Yeah, we're bumping you to next year. No, actually, in fact, instead what you should do for those people who don't get to give a lightning talk is that you should submit it as a full talk next year. So for the program committee, there's a lot more work for you now.
It's not as fast. It's more of a rolling thunder.
It's a rolling thunder talks. It's what I fall asleep to. So we also, for the first time ever, as you can see, have 2 podiums. So let's thank the AV team for finally getting 2 podiums. So how this is going to work is that we're going to have one person up giving their talk, and the other person will be preparing for the next talk. So we can switch between these much faster. So lightning fast, yeah, that's right. Make it snappy. Yeah. All right, so without further ado, I think, for our first talk, we'll have Chaya Stern. Is she around?
Yep, she's coming up.
She's coming up.
And on deck?
And then on deck, we will have James Reed. So
James can come on up and set up in the second
James,
place.
you want to set up here on stage left, and then Chaya over here.
And I've been bribed, and I do accept bribes, just so you know, for these announcements, that the SciPy survey is still up and awaiting you to fill it out. So the URL is tinyurl.com/SciPy survey, all lowercase letters. And I'll be right over here if you just want to give me some money, some food, anything like that, make any kind of announcements for you.
What'll it take to get you off stage?
That usually gets a bigger laugh.
The projector works.
Okay, it's the wrong projector, actually.
It's the wrong one.
Can we switch to the other side, please? There we go.
All right.
All right.
Okay. I'm Chaya Stern. I'm a graduate student at Weill Cornell. I study computational chemistry. And I'm going to tell you about a package that I wrote for one of my projects. It's called CP Detect, which stands for Change Point Detection. It's a Bayesian change point detection package. The reason I wrote it was because one of my projects, I had data that looked something like this. And we needed to figure out how many different steps there are and where the changes are happening. And I looked at Stack Overflow for different packages to do this, and I don't know, I couldn't find exactly what I wanted, and I figured it's faster if I write it myself. So the way this works, the algorithm looks at the entire trajectory. It calculates the base factor if this trajectory comes from one underlying distribution versus 2 underlying distributions. If the base factor is above a certain threshold that you can set, it finds the time point where that split is at the highest probability, and then you have 2 chunks of the trajectory, and it redoes that on every chunk until it stops finding splits. So it's a recursive algorithm. The way you use it is pretty much it's a one-liner. You instantiate the CP detector class. You give it a list of NumPy arrays of your time series. You choose the underlying distribution. So just to give credit, this algorithm is taken from this paper here. In that algorithm, they had worked out, so in order to do this, you need the analytic solution for the base factor. They had worked out the analytic solution for the normal and the Poisson distribution. I extended it to the log normal. You choose the underlying distribution, you choose your threshold, you run it, finds the points, and this is what the result looks like. You get a step function that, and then you can save it as a CSV file and do whatever other analysis you want to do with it. It's on GitHub. Right now, it only has the log normal and the normal underlying distribution implemented. hopefully at some point I will add the Poisson distribution. If you want to add other distributions and you can work out the analytic solution, then you're welcome to do that. All right, that's it.
Thank you very much. All right, we're gonna have to switch. We do have 2 podiums, but only 1 microphone. There we go. Next up on deck over here is Dana Miller. Now, are you around? Yes. Okay, she's in. All right, great. All right, take it away, James.
Thank you. So this is my first lightning talk, so I'm hoping for thunderous applause at the end. Yeah. I just wanted to give you a little bit of my history when I was started to learn Python about 5 years ago. 5 years ago, I learned a couple of things, and who here, show of hands, is fairly new to Python or fairly new to programming? So, okay, wow, that's great, a good number of people. So this mostly applies to you, but I think it applies to everybody. The premise is that programming is a perishable skill. You need to keep using it, and you need to keep learning. If you accept that premise, then the rest of the talk will go smoothly. Basically, everybody in our day-to-day life, we're going to get some grunt work. It's just a pile of tasks that we have to do. And for instance, one time a coworker came to me and said, hey, I have about 30 or so PDFs that have some Excel tables in them. I'd like to get the data out. And I said, sure, why not? So one way to do it is we can just apply manual labor, where the more time you spend, the more tasks you get accomplished. Or the problem is that the PDFs weren't Excel tables, they were printed Excel tables that had been scanned to PDF. So I acquired what I called parametric rage. So the further I traversed along the blue line, the more rage that I got, because PDFs are terrible. So the other option is we can program our way to victory. And I mean, with this, we all know this, right? You get nothing done for a while in terms of the tasks, but then once the program is complete, the incremental time to complete all those tasks is basically nothing, because computers are just so much faster than humans. We know this. And so you have all this extra time, and you can spend that time being more awesome. We kind of know this already. The question is, what happens when the pile is small and you can pretty easily just apply manual labor to get it done? What I'm saying is, why would we want to do it with scripting still? Why would we want to create a script? And it could be a full-blown program, but for the most part, it's scripting to complete the tasks. And I'm saying you still want to do this, especially if you're new to Python or new to programming. And the reason why is because there's a payoff. You're banking this time now, because remember, the premise, programming is a perishable skill. So look back at this graph one more time. If you put in that investment now, there's a side effect, there's a benefit, a hidden payoff, which is that you're probably going to learn something as you do the coding. You're going to learn something new. You're going to improve your programming skills. And the corollary to that is that vertical bar where you get everything done at once, you slowly move it to the left. And so you're banking time now, you're putting in your investment now so it pays off later. And not just once later, it pays off every time you have to do a big pile of tasks. And so that's why I'm advocating for everybody to script all the things. This is what everyone was waiting for, I'm sure. Thank you.
Now,
Thank you for the
those-
thunderous applause.
Well done, yes. Combining the first 2 lightning talks, you should have prior experience to expect that there's a high likelihood I would make some off-script remark.
Adam Hood, are you here?
You can kick me in the posterior later.
Actually,
All right, go take it away.
I'm projecting presentation mode. I am projecting presentation mode, which is not my intention. Gotta give it a shot.
It's thinking. It's a ThinkPad. not self-aware because it's not an iPad.
Thank you.
Yay, there we go.
Hi, I'm Dana Miller. I'm a grad student in the building science program at UC Berkeley. This means I work on control systems and network devices inside buildings. It does also mean I can talk about why this conference room may have been so cold over the past few days, but that's a separate conversation for after this talk. So my goal now is to share two things that you may not know about buildings and how Python can help us interact with buildings. But first, why do we care about buildings? To start with, residential and commercial buildings account for 40% of the energy consumption in the US. It's 70% of the electricity consumption. So that's a big deal both nationally and internationally. Two, people in urban areas, including probably you, spend more than 95% of their time inside. And we already know that the quality of that indoor environment affects your health, your comfort, and your productivity. So we know this, and yet occupants are typically still often frustrated with the buildings that they're in. Why has this been a hard problem to solve? Yes, there's commissioning. Yes, civil engineering has been around for a long time. But there's problems. For example, almost every building is a custom project. By the time you get to the documentation, it may be difficult to use. There's often legacy hardware interfaces, particularly when you consider that the median age of a commercial building in the US is 40 years old. So you're dealing with hardware that is that old, and then it will continue to be around for quite a while. There also tend to be proprietary stacks, not very much in the way of something equivalent to test coverage or version control, and yes, they're messy to patch. Paul, that was for you.
Oh, sorry.
Despite this, buildings continually generate data. This is an example from recent construction in the Bay Area. It's a medium-sized office building. It has more than 6,000 points, and they're typically not, but they could all be queried every several seconds or minutes. And these points include everything from the outside air temperature to the flow rate of water in particular pipes, to whether or not someone is in a room, to the mechanical position of a damper in an air conditioning duct. And all of these points are connected over something called BACnet, which you may not have heard of, but is an open data communications protocol primarily used for building automation and control, hence BAC. And it's become both a US and an international standard. So pretty much any commercial building that you've seen with a computerized control system is probably running BACnet. No, it's not open source. It's maintained and developed through a professional society. And so we have some data, we have some problems. Where does Python come in? Well, the thing is that people typically interact with BACnet through graphical user interfaces that look something like this, which have some limitations. And in addition, if you're interested in optimization, it's worth noting that these interfaces typically can't take any matrix math as inputs for their control sequences. So that means you are talking about PID and open loop controls. You're not going to do anything with matrix math. And typically that's it. Typically you don't have access to the network that the building management system is on. Typically you don't have physical access to that system. However, if you're in a position where you do, for example, through a field study, there's actually some tools that you can use with Python to interact with BACnet directly. So then that starts to look like this. You can run a script to discover all the devices on the network programmatically, which is useful because the documentation may not have included that. You can inspect their metadata. This is the position of a damper. You can query the points, check their name, check their present value. And again, typically you wouldn't have this access, but technically speaking, you can also write new values back and change the building controls, for example, a temperature set point in that way as well. So that's cool. And that's thanks to these two Python libraries I've listed here. There's also so this is the writing example. There's also a library or a package called SMAP, which allows you to publish BACnet data streams to cloud databases with UUIDs, and then you can use your own visualization on top of that.
And truly
that's
on
cool.
the backs of giants. Thank you very much.
So here. So we can do more. I would love to talk to people about this.
Up next on deck here is Christy Cohen. No shooting. There we are.
Can my building run not hot dog? And I thought Mr. Robot was scary. It's truly scary. Did you guys know? I think they turned my mic off.
All right. Hi, I'm Adam Hood. I'm a software engineer at JetBrains, and I wanted to talk about a project that we're working on called Datalore. So Datalore is a Python IDE for data science. Some of the features of Datalore are listed here, but instead of talking about all of those, I'm actually going to show them in a quick live demo. So this is Datalore. We have code on the left-hand side here, Python code, and we don't have anything right now, but we will have outputs on the left-hand side. So the first feature that I had listed there was this thing that we call intentions. Intentions are these suggestions for actions based on the context of your code. Right now, we have just a list of imports, not much exciting going on here. But I can click this button, and I can choose any number of popular example data sets, or I could upload a data set, and it would appear in this dialog. For the purpose of this, we'll use a blobs data set. You can see that the code was automatically generated, and we even have an output computed automatically on the right-hand side. And we also see that these buttons, the intentions, they're different now because they can see that we have this NumPy array, and we can do a lot more fancy things with that. For instance, we can create a plot. So we are working on an internal implementation of ggplot from R for this project. And right now it manifests in the form of this scatter plot that we see. Datalore is also collaborative. You can see that I have a coworker, Galina, in the audience who is currently editing this, and you can see her edits appear live as she makes small improvements to this plot. Datalore also has this feature we call incremental evaluation. What that means is as I make changes in a cell, updates are computed automatically for that cell and all following cells as needed. So for instance, if I start typing here, you can see that the blobs recompute each time, generating a new set of random blobs data. Now this is a pretty simple example. You can do a few more fancy things as needed. This is some small plots of anomaly detection. And yeah, so we are currently in a private beta mode. We are actively looking for users. We would greatly appreciate any feedback you can give us. So to sign up for the private beta, you can go to this link below, jetbrains.com/Datalore. Or if you're lightning quick, you can go visit our booth before it closes. Thank you.
Well done. I was at the booth earlier, and I found out that Datalore runs in the cloud. Lightning talk, cloud. There can be only one.
I think we need the next generation of jokes. Yames? Powell? Yames? Yeah.
I think it's yams.
Yams. James, are you around? He's outside. Well, he better get up on stage very quickly. So, and I'll hand it over to Christine.
All right. Hey, I'm Christy. I'm the projects director at NumFocus. I want to take the next 5 minutes to explore this topic of how we might measure open source sustainability. Oh, there we go. Why am I interested in that? Well, because I'm at NumFocus, and our mission is to support reproducible and high-quality scientific research by supporting open source scientific computing and data science. I think a lot of you are familiar with our work. We do this through educational programs like the PyData meetups and events. How many of you have been to a PyData? Awesome. And also fiscal sponsorship of these awesome projects, I think a lot of you are familiar with. And most recently through our open source sustainability program that we're kickstarting with funding from the Sloan Foundation. And that's what I'm leading at NumFocus. And we created this program to address this issue of these really foundational computing projects that are really getting by with very minimal resources and really don't have a plan for long-term sustainability. What do we mean by sustainability? What does sustainability look like? Well, we think that sustainable projects, they have the capacity to respond to changing circumstances, to continue to be useful and performant for users, right? So these are things from bug fixes to feature requests to refactoring to run even faster on the latest hardware and architecture. That has maintainers that aren't overburdened, right? Burnout is a big topic recently. And that the contributor base is broad and vital. And I think for that to be true, there needs to be a process for leadership development and succession. Funding is a really big part of this, but not the only thing. The goals of our sustainability program are to connect our projects with one another, to share strategies and best practices and things like that, to connect our project leads to outside expertise, to develop and provide training on key sustainability skills, to package up that curriculum that we develop for our projects and disseminate it so that the wider open source ecosystem can take advantage of it. And also to identify and provide common infrastructure to support the long-term sustainability of our member projects. I started in February, and as I'm digging into this stuff, I started thinking about how I'm going to show progress. Like, really, how are we going to know beyond anecdotal and sort of intuition that we're really making a difference in increasing sustainability? And also, how are we going to know which projects at any given time really need support? So then I started thinking, we need some kind of sustainability index. We need a value or values that give us an idea about the relative sustainability of our projects. I want to be able to have graphs like this and have an idea of over time, how is a project doing? Or maybe if we're doing our job, it's more like this. Now, what are some of the indicators of sustainability? I don't know. This is what we're currently exploring. Here are some of the ideas we've tossed around. Bus factor, right, or key man factor is another term for it. The ratio of paid to unpaid contributors. Distribution of contributors at different organizations. Something I've been calling the velocity of work. What's the frequency of commits? How long are pull requests open? Things like that. Maybe the ratio of one-time contributors, drive-by contributors, to contributors that come again and again and do increasing complex work. Maybe that's important. Some opportunities and challenges in this, right? Opportunities. Tons of publicly available data about open source projects. That's one of the really awesome things about open source. And there's prior work we can build on. There's the COCOMO, the constructive cost model of software, all kinds of stuff. There's tons of interest. Everywhere I go the last couple months, I mention this, people's eyes light up and they're like, yes, and then they come back to the booth and they have another idea. But there's challenges too. For one thing, I think some of these indicators, we're gonna have to tap non-public data sources or extrapolate. How do we identify who's being financially supported in their commit versus not, right? I think there's actually a really big gap in between the existing work and where we need to go. And we're gonna need experts and also people involved in many different kinds of open source projects to participate in order for this metric to be widely applicable. And also, I've already encountered, and I know that there's going to be many, many feels about the metrics that are important and how we talk about them and figure them out. And I'm going to hurry. So we're forming a working group. I want anyone who's interested to get involved. That's the info, and I'll tweet this out.
Thank you, Christy. Thank you, Christy. All right, up right now we have Himanshu Mishra. Are you around? Yeah, okay. Come on up. And then next on deck is Randy Ludwig. Randy. All right, perfect. Yep.
I need a
dongle.
All right, and while they're getting a dongle, I can tell you as a Jupyter core contributor and member of the steering committee, I want to invite you guys to JupyterCon in New York. That's going to be at the end of August. August 22nd through the 23rd is the training. 23rd through the 25th is the tutorials and the conference. And on the 26th, you can attend the sprints for free.
Okay, hi. So how many of you have ever reviewed a pull request made by a undergrad or someone? So how many of you had reviewed a pull request? Yeah. This is for you. And so I have around 5 to 8 slides, and in every single slide I have written a Python's Easter egg or a hidden joke. So if you already know, that's good. If you don't, thank me later. So yeah, this is what my first year students say when I tell them, okay, go contribute to a Python library. Yeah, so yeah, this is what happens. So Barry is a first year undergrad, and he creates his first pull request to a Python library. He makes himself feel accomplished. He shuts down the computer and goes to bed. While due to the maintainer is a Pythonista by heart, and due to the weird hanging indents, infinitely long lines, operators without spaces around them, and many more, he makes a single comment on the PR and referring to something called Pepit, and few others on the code he manages to read. So how does Pipit Speaks work? Whenever a new pull request is created, Pipit Speaks jumps around and says, hey, thanks for submitting the PR, but you can see these lines, they can be modified according to the guidelines that this project uses. So yeah, why don't you make another commit? And whenever you make a commit, it says, yeah, okay, there are no Pipit issues, thanks. So now I know a lot of people, a lot of maintainers are going to come and say, I don't want any more noise in my mailing list. So it's nothing like code cough or anything which makes comments after comments. So it makes a single comment. And if you don't follow the 79 columns, you can modify all of these. And yeah, it's not rude at all. So if you're afraid of that. And so what else does it do? So does it just make a single comment? Absolutely not. You can mention the bot in the comments. You can ask it to correct the syntax, suggest a diff, or even maybe create a PR to the author's branch. So yeah, here's Stephen using one. I'm very, very thankful to these 4 organizations, SciPy, AstroPy, Scikit-Image, and Scikit-Learn Country for trying it out and help me improvise the software. I really get to learn a lot solving these issues, and it's really easy to install. So yeah, and cool. And if you want to dig up on more Easter eggs, you can go to this link. And if you want to check out Pipit Speaks, you can go to pipitspeaks.com. Thank you.
Thank you. Does Paul speak?
Hey, Anthony.
Hey, Paul.
Do you want to hear a joke?
Sure, Paul.
Me too. Me too.
Next on deck is Kyle Penner. There you go. Thanks.
Hi, everyone. I'm Randy Ludwig. I got my PhD in astronomy here at UT, and now I'm a data scientist at Dell. But more relevant for my current talk is that I'm a mom. I have a 14-year-old daughter and a 2-year-old son, and I'm going to talk about data science for babies. Any parents in the crowd? How about parents of like a 1-year-old or younger? Congrats to you and my sympathies. When my 2-year-old was born, I had the good fortune. To have a healthy little boy, and didn't have a whole lot of pressing concerns except one really important thing. Will I ever sleep again? And so, because I'm a data scientist, I decided that I needed to quantitatively go about analyzing if I could find an answer to that question. Healthy babies, they don't do a whole lot. They're pretty boring. And so really all they do is eat, sleep, and poop. So that's pretty much all the data that you can gather about them. And so somebody has already figured that out. And this is an app that allows you to collect that data. You just push one of the buttons whenever you feed them or change them or when they're sleeping, and then it keeps a timer, and you can download the CSV of all their data and do whatever analysis you want to your heart's content. And so first thing that I'm going to look at is the eating habits. So this is over the course of about 8 months. So on the time here, we have at the top the total amount of time eating per day, number of times he ate per day, and the average amount of time he ate per day. So this is showing that I'm spending 2 to 6 hours of my days feeding him, and that means that 8 to 18 times a day I have to drop everything and feed the baby for 10 to 30 minutes at a time. So that's what life looked like, especially when he was little. So, especially because a lot of those come at night, figuring out the eating habits is relevant to my sleep question. So let's see what happens. Well, if I fit the amount of time he spends eating per day, I tried lots of different models. Here we have a polynomial fit and a broken linear fit. Looking at my chi-squared values, my broken linear fit is the better option, and so that's the one I'm going to go with. So then if I extend that into the future to when the eating time goes to 0, when will he not need me to feed him anymore? It turns out that's at about 2.5 years, which actually, if you look at the literature, is pretty consistent with baby self-weaning time. So hey, my personal data for the win, like, as being representative, I guess. But also, that's a terrible, terrible scenario. I don't want to only get to sleep when he's 2.5 years old. So let's hope that's not actually true. And in fact, it's not true. He doesn't nurse anymore. So, and he's 2 now. So what about other data sources? We looked at eating, let's look at sleeping. So I have here, all those little orange spikes are every time he ate in a given day. This is from 0 to 24 hours on the x-axis, and all the blue periods are when he was sleeping. So this is when he was about 7 months old. So he has a nice long night sleep and then 2 naps in the afternoon, or mid-afternoon and late afternoon. You'll notice as the son of 2 astronomers that he's a night owl and doesn't go to sleep until after midnight and sleeps until like 11 a.m., which is what we do too. So hey, it kind of worked out for us. Add these up over all the times of day and you can see what his patterns look like over time. The one thing I want to point out is that orange part at the bottom, that's just kind of a continual level in the background, is telling me that there's not any particular time of day he eats, he just eats all the time. And so the other thing I wanted to point out is that at the beginning, I wasn't actually taking sleep data. So June here, you notice there's not any, and then it starts to come up. It's really messy, and also the sleep period starts actually more like 2 a.m., and then as you watch the months go by, you see it shift earlier and earlier. So we managed to pull him to a little bit of a less crazy sleep schedule. But then if you look at the nap section, the second half, it's like really, really jaggedy and then kind of settles down into these 2 peaks where there's like 2 afternoon naps. And that happened just around the 6-month transition point is when you start to notice that. But relevant to my sleep question, that orange line is still going all throughout the long night sleep cycle, so there's not any particular time of night that I get to sleep. Unfortunately, I did not collect poop data, so you're out of luck there. So for answering my personal question, when will I get to sleep again? In fact, last night was particularly awful for reasons I don't know. Anyway, so for him, I mean, like, he was up all night. Anyway, what I wanted to share with this talk was it really super chaotic, especially when he was little, or did it feel like that way just because I was sleep deprived? And the answer is it was chaotic. And also to other parents in the crowd, you're not alone. It really is chaotic.
Thank you very much. Unlike Paul and I, you're certainly not kidding. All right, next up on deck, we have Jane and Alyssa. Jane, Alyssa. Oh, there we are. Great, perfect. All right, take it away.
Hi, everyone. Howdy, y'all, in Texan.
Howdy.
My name is Kyle Pinner. I'm a postdoc at the National Radio Astronomy Observatory, and this is going to be my thank you to AstroPy and ApplePy and the people who make my job easy. I'm just going to show you some images that I've made using all of these tools. The images that I make have a countable number of objects in them, and so sometimes we just like to go through all of those objects and just glance at them. So what you see here is what you see 4 images. Each image is at a different color, and in all of these images, it's just a galaxy. So in this This galaxy has a lot of this color, none of blue, which is F435W, if you can see that. So that's that galaxy. Then I can also make these images with a particularly nice RGB image that you might see in some magazine somewhere. And you can see that in all of the colors shown here, this galaxy seems to be bright. Hooray. So you have, let's see, blue. This one is blue here. This one is green. And this one's in the near infrared. And then, so this is an RGB image, and you can see this arc here. And that arc is a distorted image, and the distortion was made by one of the most massive gravitationally bound structures in the universe. So hooray. Here's another one. This galaxy was detected in this image and has a lot of this color, which is at a radio wavelength. And it's absolutely not seen in any of the visible bands. So if you were to only look in a visible wavelength image, you would not see this galaxy at all. Thankfully, we have the radio data and we can see it. And then again, here's the false color RGB image. Here's another one. This one's just pretty. Yeah. So this is like default. I have not messed with any of the defaults in Apple Pie, and it just produced that RGB image. So congratulations, you guys. You did a really good job. Here's another one. Sometimes our catalogs have spurious detections, and something that it just the source finding algorithm just caught onto a noise peak, and that's what you see here. There's no galaxy. Well, no, there are galaxies in these images, but not the ones that we think are at the center of the image. And here's the last one. Again, just pretty images. Like this is blue. This color here is blue. This color here is green. Yeah, I'm done. So. Thank you.
All right, thank you very much. All right, so up next on deck, we have Santosh. Santosh? Great. Oh, sorry, your connector is right there.
All right, so since I have an opportunity to do a little bit of light potty humor, I wrote a new package called Schrodinger's Cat. And just like the Unix cat utility, except it may or may not print out a line, right, of a file that you're doing. So you can pip install scat. It's kind of a crappy name.
That won't cut into your time.
Good.
Wiping the slate clean?
So today we're going to be talking about the Clover Health's Associate Software Engineer Program, both of which we are participants in.
Clover Health is a Medicare Advantage company, and we're a startup in San Francisco and New Jersey. And our basic premise is that we have a lot of data scientists and engineers, and we're trying to use data to improve the quality of care and health of our members.
So a little bit about both of us. We both don't have a traditional computer science or engineering background. I was an undergraduate at Middlebury College where I studied geography, worked as a data researcher briefly, and then attended Hackbright, which is an all-women's engineering boot camp in San Francisco, and then worked as at an energy efficiency company as an engineer, and before starting at Clover.
And I got a degree in math and econ at UCLA, and I sort of fell into healthcare. So I interned at a human resources consulting firm in college, and after college I was a pharma and biotech consultant, a data analyst at an insurance company, and I originally joined Clover as a analyst on the data science and analytics team. So where did our ASE program come from? It's helpful to look at a timeline of the company. So in 2014, we were just getting off the ground, and our office was literally our CTO's apartment. In 2015, we got our first round of funding, and we started to hire a lot of experienced industry and tech people. In 2016, we had massive growth, so we had a lot of funding, and then we grew from about 150 people to 500 people, which is huge. And then the engineering team split into functional teams. So by mid-2016, we had a huge engineering team of experienced contributors, and they really wanted to mentor other people and be mindful of what it takes to be a diverse organization. So by Q4 of 2016, we launched our ASE program with 7 participants, predominantly female, and we had one former intern who was a part of Code 2040, which is a program that encourages Black and Latino people and helps them get into engineering departments.
So a working group formed of engineers who were interested. They met regularly, produced, as you can see, a lot of documents, basically outlining how the program would work and what the curriculum would be and some guidelines for mentorship. And they came up with, you want to do the next slide? The following components of the associate program. The 6-month program, the expectation that you'll be hired as an associate, provided support and mentorship, and after 6 months, you'll graduate to be a level 1 software engineer. You have a dedicated mentor throughout the process. This person serves as your buddy for the projects that you're working on. It's your go-to person for questions, whether that's technical about the work environment, et cetera. And this is a great opportunity for pair programming as well as shadowing in order to understand how to make wise technical decisions.
We also have weekly teaching sessions, so engineers across the company will present on core concepts and topics. And just some examples from our ASE period were command line fundamentals, Postgres queries and profiling, Python debugging, common Git pitfalls, pipelines and data flow, Airflow, JavaScript fundamentals and debugging, and the history of DevOps. And every week, we'd also have a dedicated engineer who would do office hours, so the ASEs can drop in and ask any sort of questions they want, whether it's like technical, company-related, or specific to the teaching session. So it's been about 8 months since we started the program, and we have a 100% retention rate with the ASEs, and we have positive feedback from both the mentors and the mentees. The mentors meet weekly amongst themselves to discuss progress and their personal reflection, and the ASEs also have retrospectives with the program operators and leaders every couple of months. And then the ASEs have actually gotten to a point where we've specifically requested different teaching sessions that we were interested in.
So overall, we found that explicitly valuing mentorship and individual growth has contributed to building an open and inclusive engineering culture at Clover Health, both of which we have enjoyed and benefited from. So if you're interested in more details about the program, how to get a similar program started at your company, or our experience in general, please contact us. We have our contact information here. Also, shout out to Matt Davis, who's not here, who many of you know. He's my manager, and you can contact him too, Jiffy Club.
Thank you very much. Sounds like a great program. All right, next up on deck is M. Pacer. No, there we are. Great. Take it away.
All right. Hi, everyone. I'll try to make it really quick because I need to catch a flight in an hour.
Yeah, you're not going to have that much time.
Yeah. All right, my name is Santosh, but some people call me Santosh, which is the right way to say it. Okay, I'm from MSU, Michigan State University, and I work for the RDP group there. Our group specializes in bacterial classification using 16S ribosomal gene. That's what you're mainly known for, and we've been there for like more than 15 years or so. So we have some online tools that does 16S processing, data processing that microbial ecologists use to classify bacteria. But this is old stuff, and since sequencing is so cheap nowadays, people just assemble genomes, and so we developed a system where you can process and manage microbial genomes, and it's called MIGA, and it stands for Microbial Genome Atlas. Is it not too loud? Sorry. And one of the things it does is it's a genome-based taxonomic classification system, and you can visit the website here, which is microbial-genomes.org. And you can upload your genome here. You have a couple of options. If you have an assembled genome, that would be the best way to do it. But another option you have here is it's called a pop genome, which is like if you have a metagenomic data set, which is pretty much which is a environmental sample, which has all kinds of bacteria. So if you have a population genome, meaning if you got it from metagenome, you can use it as you can use the pop genome option here. But what the tool does is it goes through the pipeline to basically classify on comparing it to 10,000 genomes that we have curated, which you can find here. But if you do query a genome, this is a Bacillus cereus genome. We go through the whole, if you gave us raw reads, it would do the assembly, gene production, and do some annotation, finding the 16S gene. But the main thing it does is using some genomic metrics, we developed a platform for getting you the closest genomes that are available based on your query genome. And that's about it.
Thank you very much. And it is now time to fly. All right, so right now we have M-Pacer, and up next on deck is James, I guess. Snuck up behind me. All right, take it away.
Wonderful. So, as you've heard, I'm M-Pacer. I work on the Jupyter project. I'm a postdoc there. I also work on the IPython project, and I have some news for you from the IPython community. So, the first bit is IPython 6.0 has been released. It's actually on 6.1 at this point, and that is a Python 3 only IPython. So first, yeah. Woo! So, now you Python 2 people might be worried that you go and you pip install and update your IPython and that it breaks for you. And that almost happened if we hadn't been trying to be careful about it, and what we've done a bunch of work to try to make sure that that doesn't actually happen. And now you don't need to worry. All you need to do is upgrade pip and upgrade setup tools if you're a developer, so that you can add the Python requires metadata to your package, and then say that it is Python 3 only. Then Python 2 people, when they try to pip install and upgrade, they will not get the Python 3 package, and it will not break their systems. So now that should be getting applause. We're not breaking things for people while moving forward. If you want to know more about all the details about what needed to change and everything, there's a talk at PyCon that Matthias Buissonnière and I gave. The slides are at caro.github.io, PyCon 2017, and the video of the talk can be found at tinyurl.com, ending Py2 compatibility. This also applies if you're a developer that wants to move the future forward without breaking the past. Next step is on master right now. ipython.display.display is a built-in. That is, I can just go and run display this bit of code, and it works. I did not need to import ipython.display from ipython.display, import display. It's just there. This is often used in the context of, say, data frames and whatnot. So yeah, making your code look nicer, don't need to include that. And so this last bit of news, so this is one of the things that sort of is perennial conflict, or at least challenge for the SciPy community. That is this intersection between open source software and academic credit. One of the steps for that to move beyond that is to, say, get things like JOS or JOES, where you have software actually being credited for the important role it is in publications. Another thing is finding actual professorships that are being given to people on the basis of their contributions to the open source community. And with that, I would like to give a great thanks to this next professor of statistics at UC Berkeley. They'll be teaching reproducible research this fall. Please give me a round of applause for Fernando Perez. And with that, I bid you adieu.
Wow, that's what I call lightning talk. All right. Right now we have James, who wants his phone for some reason.
I can time myself so I can see if I'm going too fast.
And up next on deck, grab the wrong sheet. We have David Shoup.
This talk's so stupid.
All right, perfect.
Okay, let me get started. I don't have a lot of time. I'm sorry this lightning talk is really stupid. It's about a piece of software that I put together very recently on a flight when I was really bored called Gormless. By the way, I'm James Powell. If you want to follow me on Twitter, I'm Don't Use This Code on Twitter. Remember that because you really don't want to use this code. You might wonder, why is it called Gormless? Well, I wanted to write an ORM, and I wanted to write the ORM inside of Postgres as opposed to some separate middleware tier. And so you can think if it's in Postgres, you might call it PG ORM, but I don't really want to write an ORM because I think ORMs are terrible. So naturally, you might call it PG ORMless or simply Gormless. And what's really surprising is there is no package out there that I could find that uses the name Gormless that's related to ORMs. So I struck on something at least good, which is the name. Now, I don't really want to talk about this piece of software because it's a really stupid piece of software. What I want to talk about instead is domain modeling. But the problem is, nobody cares about domain modeling. I can already see you tuning out. I know you don't care about domain modeling because the moment I say that, everybody, their eyes just roll in the back of their head. And you might look at me and you say, there's that guy up on stage in the suit, and he probably comes from the finance industry, which is true. I do come from the finance industry. And you might say, well, maybe those folks in the finance industry, they do care about domain modeling. But the thing is, they don't care either. Because most of the people here who come from the finance industry, who come to events like SciPy, they work in the equity markets. And when you think about the equity markets, it's mostly things like signal analysis. No component of business modeling or domain modeling whatsoever. I come from the fixed income sphere, and when you think about the fixed income sphere, it's not as sexy as the equity markets because fixed income basically means bank IT. When you think about bank IT, it basically means reporting systems. And when you think about reporting systems, you think about things that are modeling actual things that exist in the real world, tangible entities like the money in your bank account. In fact, I spent a lot of my career building things like P&L systems, and P&L systems, a good P&L system, will give information to the trader to make his decisions, where that information can tie directly to the actual physical amount of money in the bank account. And I worked on one or two systems that could do that. Well, when you think about that, the objects that we're dealing with in this system are things like bonds and CDS. They are somewhat real-world objects. They are mathematical in nature. CDS are very mathematically complex structures, but they also are primarily entities which have some human, social, or legal structure to them. They make sense to you from a mathematical perspective as curves, as points on a curve, but fundamentally they are legal contracts that exist between two parties. As a consequence of that, they exist in the human world. They have irreducible, infinite profundity. There is no way that you can tell me that you can regularize the entirety of all the products in the fixed income market in one simple model because there is no limit to the amount of complexity they can have. For example, simple products that you might want to trade are end-to-default CDS, insurance contracts where they pay out when a certain number of entities default, or elements that pay in kind. So you have things that don't pay money, bonds that don't pay money, coupon of money, they pay in more bonds, maybe not even themselves. Or things like entities that settle in multiple different currencies on weird schedules. Or I briefly worked in loan origination, and in loan origination, there is no limit to the amount of complexity of the terms of a loan outside of what the lawyers think is reasonable. There's absolutely no limit there. There is no limit to the complexity of anything that we try to model in a computer based off of the real world, but what the human imagination come up with. Thus, people care about domain modeling when they have problems that look like this, when a critical aspect of the problem is not its mathematical nature, but how it coexists within the real world. When we do domain modeling, the purpose of this is to understand the critical aspects of something like a bond or a CDS, to regularize it, to remove this infinite profundity, to say we won't deal with structures which have certain legal aspects because our system doesn't have the ability to do things like determine private-public registration types on bonds. That's not what our system's about. We'll limit it just to the qualities that our system can actually do operations on, which mostly is, automated trading, limit orders, or just the computation of how much this thing is worth. There is a lot of map territory confusion in this space, which is why domain modeling is so critical. Typically, what I found is domain modeling fits very nicely into a relational structure, which is distinct from the mathematical problems you want to solve on these things, because usually the mathematical nature of these things fit into n-dimensional structure. So we have two fundamentally different ways of structuring this data, relational and n-dimensional. We have great tools for modeling relational data, namely SQL DDL. We have terrible tools for manipulating it. Thus, people build ORMs to meld these two worlds together. Except ORMs are terrible. We've all used them before. They're horrible. They are a nightmare in our world. And what they end up doing is when you design through the ORM to the DDL, you have terrible DDL. So instead, what I want to do is do the domain modeling first with a tool that I call Gormless. So here you can see an example of some code. What I do is I select something out of the database using raw SQL, and what I get is a raw Python object, because what I have the ability to do is create a view on a table in my database that pickles a Python object into that. So I can actually select raw Python objects out of my database. This is what the function looks like. You can see, you can just embed Python into SQL. Since it's a raw Python object, I can do things like, say, .name. I can also do things like subsequent queries. 3 more slides. And I can also do something really cute.
He's calling the shots here.
Like, I don't know.
Yeah, that's a good question.
Like coordinate context managers and CTEs. And so, the reason that I did this, and here's the last few slides just for you, Anthony, before you kick me off the stage.
Tell me all about it.
It was a fun project. If you're interested in domain modeling and you're interested in maybe doing things better than ORM, come talk to me.
Zero indexed.
Domain modeling is very important. You can connect these things to an ORM and you don't have this really clunky middleware. You can better handle the object numerical relational modeling. But unfortunately, this is a really dumb idea and a really dumb project, so you probably don't want to do it. Thank you very much. I'm James.
Thank you, James. Don't use this code.
Don't use this code.
Oh, that's okay.
Any finance joke I make at this point would just be derivative.
I got a joke. How can you tell if Anthony's telling a joke? Nobody's laughing.
Oh.
Sick burn. Peter? Take it away, David.
We all love each other. It's a good time. We all love each other, right? I love you guys.
We love you,
I love
Paul.
all of you.
I love you so much, I'll take away your mic.
Hi, I'm David Shoup. I'm an astronomer at Caltech working on the Large Synoptic Survey Telescope. My GitHub is Stargazer that comes from my California personalized license plate. So I'm going to be telling you about Python widgets for astronomy visualization. And this is based on a framework that we've developed at Caltech called Firefly, which was developed for the Spitzer Space Telescope data archives and has been used for many other astronomical archives. So the idea is you have your pipeline producing data, you have some sort of retrieval system and a user workspace. And then Firefly consists of 2 components. There's a Firefly server that's sitting close to your data and a Firefly web client that the user uses. And what's going to be done for the LSST, the telescope that's going to produce lots and lots of data, I think 15 terabytes of data every night, is to have all of this stuff in the box be in the cloud with a workspace, a remote workspace for every user. And then Firefly is a way to visualize that remote data as if it were local. So it's been used for many astronomical archives. We use it for serving all the data from IPAC from various space missions. So what I've been working on are widgets. So what are these widgets in the in the Jupyter sense, and I was just told today for Jupyter Lab that the nomenclature is going to change because widgets is an overloaded term. But you have a widget in your Python kernel, and it also exists in JavaScript, and then they talk in between each other. And the work is done in synchronizing these two. So I might have an attribute called color bar. I want to manipulate it on the left-hand side of my notebook session, and I also want it to have a user control for that and have those synchronize. So we have a package called Firefly Widgets that has interactive widgets for both images and tables. It's kind of in an early state right now. Here's a GIF showing one of these widgets. We also have a table widget that can handle large tables, and it has a lot of nice user filtering capabilities. And at this point, I wanted to go to the live demo. So I've already loaded from our public server at IPAC some images, and I've hooked them up to SciPy widgets. So on the left, I have an image of the Ring Nebula, and the right is M51. So you can do all kinds of linking and unlinking between these widgets. And I can also use the Firefly built-in zoom and pan, and it will also synchronize back to the notebook. And likewise, I could do the same for color bar. Back to Keynote. Then, so what are the lessons learned? I want to get to the lessons learned. So use the cookie cutter template for your Jupyter widgets that incorporates the best packages for packaging and makes the installation very straightforward. At least for this project, I found the development was pretty light on the Python side and heavy on the JavaScript, but that's mainly because we have a JavaScript interface to our Firefly server. And only some of the actions are good candidates for widget attributes. So if something is, because some things are done on the client and you can change it very quickly, some things require a callback to the server, actually like changing the color bar, which can be slow. And so you can find Firefly widgets on the Caltech IPAC repository. The Firefly server, you can use the public server that's at IPAC or run your own with Docker or Java. And if you're interested in talking about widgets, I'll be around for the sprints all this weekend. Thank you.
Thank you, David. I love synchronized fireflies. And for our very last lightning talk of SciPy 2017, we have...
Oh no. Could it really be?
It's over. I'm sorry. Aww. Look at all these people who don't laugh at your jokes.
I know. There's never been so many people not laughing at my jokes. This is...
Yeah.
I've always also wanted to share a stage with this man, Peter Wang. So now that's happened. Now my SciPy is complete.
You complete me. So I got a joke of my own. Why are SciPy lightning talks like a box of chocolates? Because you don't want playing to go first. That's why. And the reason, for those who may be aware, the reason you don't want me to go first is because years ago, I gave a not-so-lightning talk that went on for 20, 25 hours or something? 30 minutes?
This was the best talk ever. Look it up.
Depends on who's counting. But what I was talking about, and I couldn't shut up about it, was I was expounding about my concerns about Python's growing popularity, and especially as it was starting to enter into business environments and enterprise sort of settings. And I was worried that as a community, if we didn't do things right, that we'd actually lose a shot at this growing adoption, that we'd lose credibility in business environments and kind of end up in just this little weird niche populated by scientists for the most part. But what I wanted to see was that what are the things that we could do to really grow Python really on a massive global scale. And I encouraged people to think about growing the community. I encouraged people to think about doing evangelism in a very intentional way, a very inclusive way, and being respectful of other languages and technologies, things like that. And now I guess we're, what, 5 years, 7 years? 7 years, something like that.
Time flies.
Oh my God. But the point is, I think it's clear to all of us that in the time since then, as a community, as devs, as learners, as researchers and organizers, authors, all of you all have succeeded massively. So I congratulate you. Mission accomplished. Even President Bush is, ex-President Bush is a fan of your work. And so, you've all succeeded. We've all succeeded. And we can sort of say that definitively open source has won or is in the process of massively winning, right? So I think that deserves a big round of applause. So if we've been successful in beating the drum on open source, what happens next? What's next? And what's next really depends on how you look at the value. I think it's a discussion around what is the value of open source software. We've had discussions about sustainability, and there's a lot of discussion about sustainability of open source now in the community, which I think is really wonderful. And the way I see it is that actually the value of open source software depends on your view of just what is software in general? What is the value of software to you? And some businesses, they see the software as an embodiment of their intellectual capital. And in those cases, they actually tend to go to proprietary licensing and proprietary software because it justifies the expense and the cost of maintenance, because it's sort of an intellectual capital investment. Now, for more and more of the world, however, software is actually an operational aspect of the tech infrastructure. And in that operational context, you're not making the most efficient use of resources if you shoulder the burden purely by yourself. So some people who see software as being part of their operational infrastructure, they look at open source. If they're fixating on features, they look at open source and they say, hey, that's great. I get my features for free. It's free beer, right? That's really that naive view. The free open sourcey stuff, I get my features for free. Slightly more sophisticated people who've been around the block a little bit, they understand that there's actually maintenance of all the software. And so they understand open source to be actually a community that can maintain software, which means I can keep getting free beers tomorrow, right? So there's sort of like the spot and then the time rolling forward view. But all of these things still, really you're looking at software as are you looking at software as a part of your operational infrastructure? Are you looking at it, as something that has is a capital investment essentially? And that's the root question, right? Is software a means to an end, or is it an ends unto itself? And what I would contend is that the world is producing more and more software devs. My son this week is wrapping up, as a 7-year-old going to 2nd grade, he's wrapping up a week-long coding robotics camp at a local children's museum, and he's been doing all manner of interesting things. There are more and more software developers. He will become a software developer well before I retire. And so there's going to be more in the world. And more importantly, dev tooling is getting better. We are learning how to stand better and better on the shoulders of each other. And so what this means is that there's going to be fewer and fewer situations where software as an ends can really remain defensible as a high margin activity unto itself. And so that's great, because that means there's going to be more and more open source software. And yet, if you think about the flip side of it, what it means is that fundamentally businesses are going to operate more and more in this mode where they're coupling software with hardware or with the data offering or with some other kind of lock-in mechanism to recoup their investment. And so we may be actually beginning to win the open source battle if you contextualize that statement purely on the basis of licenses. But are we winning the war? Right? What is the war really about? And so briefly, I will basically look at what I see as the 3 eras of software. In the very first early era, this is Nicholas Wirth's famous book, it was very data-centric, or sort of schema-centric, which led to procedural abstraction and sort of the things that built out all the infrastructure in those early data systems that actually many of us, our payroll, our Social Security, everything else rolls through. The second era really went to doing model-centric, business applications, actually the stuff that James was talking about. And it was about building these encapsulated business objects that could reflect and do change management on business logic and things like that. But what is the third era of software? Because these things are still, like if you look at the TOB index and things like that, Java, C++, .NET, they're very popular for building these kinds of applications still. I think we're entering into a third era of software, which actually sort of bifurcates. And it bifurcates in this way, that there's some kinds of software that are more service-oriented plumbing. And basically they take data from real-world sensors or systems, they put them into back-end systems to do some transfiguration, and that triggers real-world actuations or things pumping into eyeballs. And then there's a second kind of software, which is really a component of an entire analytical system. It's part of that computational drivetrain that fundamentally is about augmenting human inferential capability. So those are sort of the 2 bifurcations I see in what software activity is about. And this data system versus infrastructure cleave, I think is the akin to the hardware-software split, which has really dominated our thinking about software over the last 40 years. I think we're moving into a world where it's no longer sufficient just to say, is this a piece of open source software or not? You have to look at that software in the context of the larger analytical system it's part of. And so with that, the question is, what are the core principles behind our community's ethos of open source? Right? Open source in the context of software meant something. Is it about transparency, innovation, inclusion? Is it about empowerment of individuals with great ideas? Is it just about avoiding MATLAB? What is the actual core principle here, right? Please don't take a picture of this and tweet it. And so
good enough for me.
And so the reason I posed this question, I have no answers here, but I posed this question just to get people thinking about it, to whet people's intellectual appetite about this, because we cannot afford to have sloppy thinking about this. If we don't think about this clearly and be intentional about this as a community, we may march forward cheering on, oh, this is open source and that's open source, and all these things are open, when actually that no longer is the most salient question. Right? Maybe what we're really fighting for, we've been fighting for the last 15, 20, 30 years, for many of you here, for open source and openness in science and in analysis and data science, those principles might shift to a different, manifesting a different set of things in this newer era of software. So the really amazing thing, right? The scikit-learn logo was on the Apple keynote. Like, the important thing here that's interesting is the SciPy, Python, PyData community. This is a place where these conversations can happen. It's a place where these conversations can send ripples throughout the entire world and actually set the paradigm for how human civilization actually engages with the next generation data systems and augmented reasoning and cognitive systems. So I would encourage all of you, after a few drinks, to think about this and really kind of, don't let this rest. This is actually a really important thing that we can be at the vanguard of. Thank you all.
Thanks for not having any of the answers, Peter. All right. And any last one-liners you want to get in?
No, just thank you so much. This was a lot of fun. I hope you've had a great SciPy.
Let's thank all our speakers once again for the whole conference. And I think, hope to see you at Sprints tomorrow. And I hope you had a great SciPy.
See you next year.
2018.